Hello everyone, welcome to MEMONEET. I'm Sarthak. I'm a master student at IIT Roorkee and a content creator at MEMONEET. So today we'll be discussing the chemistry portion, the solutions of the part test 2. Let's start off with the section A, question number 51. The question says, what will be the ratio of the orbital angular momentum of electrons with L is equal to 2 and L is equal to 3? Okay, so we are given the values of L and we have to find out the ratio of the orbital angular momentums. So the formula for calculating the orbital angular momentum is h multiplied by L into L plus 1. So we just have to substitute the value for L. First, when we put the value of L as 2, we'll get the value of orbital angular momentum as root 6h. Okay. And then we put the value of L as 3 and then we'll get the value as root 12h. So when we find out the ratio for L is to 2 is to L is to 3, so we'll get root 6 is to root 3 root 12 and we'll get the answer as 1 is to root 2, which is we can see in option 2, which is the correct answer. Moving on to the next question, we have choose the correct statement, and we have three statements and we have to tell which of the following statements is correct. So statement A says helium does not form clathrate compounds with quinol. So this is a correct statement because as we know, helium is an is a noble gas, and so it will not react with any compound, right? So it will not form a clathrate compound with any molecule, let alone be quinol. So statement A is a correct statement. If we take a look at statement B, it says xenon does not form fluoride such as XeF, XeF3 or XeF5. Okay, this statement is also true. Why? I'll just discuss it. As we know, xenon has eight electrons in its valence shell, so it has a complete octet. So for forming a bond, if we have a paired electrons, so one of the electrons has the pairing has to be the paired electrons have to be unpaired, right? So when the electrons will be unpaired, we'll have two unpaired electrons, right? So it will have to form two bonds minimum, right? So if xenon is forming a bond, so it will be forming even number of bonds always. So that is why it cannot form XeF, XeF3 or XeF5. Although there are compounds for xenon as XeF2, XeF4 and XeF6, because it only forms even number of bonds. So statement B is also correct. Now, if we take a look at statement C, it says fluorine does not give fumes with moist air. This statement is incorrect as fluorine reacts with the moist air and it produces HF. Okay. So statement A and C are correct and statement C is incorrect. So the correct answer for the question will be option 3. Moving on to the next question. The question says, which one of the following conditions will favor maximum formation of product in the reaction? And the reaction we are given is A2 gas plus B2 gas gives X2 gas. And the reaction is given to be an exothermic reaction as the enthalpy change is negative. Okay, so first of all, you need to understand in reactant side we have 2 moles of gases, whereas in the product side we have only 1 mole of gas. So that means when we increase the pressure, so the equilibrium will shift in that direction where lesser number of gases is present. So we need more production of more formation of the product, right? So if we increase pressure, reaction will move towards the product side. So on increasing pressure, the equilibrium will shift in the forward direction. So first of all, our first condition has become that we need high pressure, right? Now, if we talk about temperature, so we know that in an exothermic reaction, if we decrease the temperature, so the reaction will always move forward. Okay, so for an exothermic reaction, temperature should be low to favor the product formation. So we need high temperature, high pressure and low temperature, and that is in the question in the option 1, right? So correct answer is option 1. Moving on to the next question, it says arrange the following in order of their acidic strength. Right. So we have three compounds and we have to tell which of the following is strongest acid. Right. So if we take a look at ABC, so this carbon atom which I am highlighting right now, this carbon atom, this has a hydrogen, right? And this has a hydrogen and this hydrogen, right? So these compounds, these are the hydrogens that we'll be discussing about. So when the proton is lost, right? So there are two things for acidity that are necessary. First of all, there must be high electronegativity, and the second thing is that the carbon ion which is forming should be stable. So if we take a look at compound A, we have 5 CF3 molecules on this, and we know fluorine is highly electronegative. So there are 5 electron withdrawing groups on the compound A. So it has a high tendency to lose the protons. Moreover, as we see, this is a 5-membered ring, right? So we have a 5-membered ring and it has two double bonds. So when a negative sign is here, we can see that the ring has become aromatic. So due to this aromaticity, the carbon ion is very, very stable. So most stable will be A will be the most A will be the strongest acid. Now if we take a look at compound C, so in that we don't have any electron withdrawing groups, but after the loss of electron we get a aromatic ring, right? So C will also be a strong acid after A. And if we take a look at B, so when compound B loses a proton, this is formed. And as we can see, there are only 4 pi electrons in this, right? So due to 4 pi electrons, the system is anti-aromatic. So it will not prefer losing a proton and forming this carbon ion. So B will have the lowest acidity of the three. So the compound final answer will be for question 54 as option 3. Moving on to the next question, the question says the product of the reaction given below is, and if we take a look at the reaction, this is the reaction that we have. So in this we have an alkene and we are reacting it with a uh, N-bromosuccinamide, and after that we are reacting it with water in the presence of a in the presence of a base. Okay, so what we know about N-bromosuccinamide is that it carries out the reaction, it carries out bromination via the free radical mechanism, and it prefers allylic as well as benzylic positions. Okay, so if we take a look at our compound, we have a double bond. So the carbon next to the double bond is known as the allylic carbon, right? So these are the two allylic carbon we have, right? And these are the two possibilities that we will be having for the formation of other compound. However, in this case, if the bromine atom is attached here, right, it will face a certain steric hindrance from this uh, from this chain attached, right? So that is why this will this option will be more stable, and here the bromination will take place. Okay, so when the bromination takes place, this is formed, and in the presence of base, when water reacts with the bromo compound, so we'll get an alcohol here, right? So the correct answer can be seen in option 2. This will be our final answer. Moving on to the next question. The question says, what is formed upon complete hydrolysis of R3SiCl? Okay, so this is a easy question. This is a memory based question, but some people make mistakes in this because uh, when we do the hydrolysis of R3SiCl, we tend to think that R3SiOH will be formed, which is absolutely correct. But after R3SiOH is formed, what happens is that two molecules of this compound, they condense together to lose a water molecule and form a dimer like this. Okay, so the product that will be forming is in option 2. So option 2 will be the correct answer, not option 1. So we have to keep this in mind. Moving on to the next question. The question says, identify the statement that is not accurate from the following options. So we have 4 different statements and we have to find out which of the following statements is incorrect. So if we take a look at the first statement, it says increasing order of reactivity among group 1 elements is lithium, sodium, potassium, rubidium and cesium. So this is the correct statement because we know that as we move down a group, the metallic character increases. So that is true for all S block elements, that as we go down the group, the metallic character, as and by that we mean the reactivity will increase. So statement 1 is a true statement, so that cannot be our answer. If we take a look at statement 2, it says that oxygen has a lower ionization energy, lower first ionization energy than nitrogen and fluorine. So let us draw the electronic configurations for nitrogen, oxygen and fluorine. So if we draw the valence shell configurations for them, for nitrogen we have 2s2, 2p3, right? For oxygen we have 2s2, 2p4, right? And for fluorine we have 2s2, 2p5, right? So if we take a look for nitrogen, in nitrogen we can see that we have a half filled electronic configuration. We have p3, right, and all orbitals are filled with one electron. So this is a half filled electronic configuration, and that is why it is more stable. So because of this stability, nitrogen has a higher ionization energy than oxygen, and obviously fluorine will also have a higher ionization energy than oxygen because it is towards the right side of its right side of oxygen in the periodic table. So oxygen does have a lower first ionization and enthalpy than nitrogen and fluorine. So statement 2 is also correct, so it will not be our answer. If we take a look at statement 3, it says ionization of beryllium is more than that of boron. So once again, let's take a look at the electronic configurations of beryllium and boron. So beryllium is 2s2. So it is a completely filled s orbital. Whereas in case of boron, it is 2s2, 2p1, right? So boron will be more, boron will tend to lose the electron faster as compared to beryllium, because when it loses the electron, it will form a stable, it will form a kind of stable configuration, which is 2s2 with a completely filled s orbital. So ionization of energy of beryllium is more than that of boron. This is the correct statement. So option 3 can also not be our answer. So option 4 will be the correct answer. What does option 4 say? It says that the second ionization energy of nitrogen is more than that of oxygen. This statement is absolutely correct, because as we saw here in the electronic configuration of oxygen, so if oxygen loses one electron, it will form a stable half-filled configuration. So it will not want to lose the second electron. So the second ionization enthalpy of oxygen is lower than nitrogen. So correct answer will be option 4. Moving on to the next question. The question says, determine the total oxidation number of 3 oxygen atoms and 1 carbon atom in the carbonate ion. So they are talking about the carbonate ion. We know carbonate ion is CO3 2 minus, right? And they are talking about the total oxidation number. So the total oxidation number of a molecule is same as the charge that it is carrying. So that charge is known as the total sum of the oxidation numbers of the individual atoms. So the correct answer will be -2. Also, if we find out separately for each of them, so in that case also, if we will have to draw the structure for carbonate ion. So if we do that, it will have one double bond and one single bond with each oxygen carrying a negative charge. Okay, so there is a -2 sign here on this, a -2 charge on this, a -2 on this oxygen, and the carbon will be in +4. So in total, we'll get a -2 sum of the oxidation numbers. Moving on to the next question. The question asks, which of the following is a colligative property? Option 1, osmotic pressure; option 2, vapor pressure; option 3, boiling point; and option 4, freezing point. So we know that colligative property is a property that depends only on the number of particles present, right? It does not depend on the type of or the nature of the particles which is present. So colligative properties, we know we have studied 4 colligative properties. One is the relative lowering in vapor pressure. We studied relative lowering in vapor pressure, not vapor pressure, right? So vapor pressure is not a colligative property. The elevation in boiling point, not boiling point. The elevation in boiling point is a colligative property. Similarly, the depression in freezing point is a colligative property, not the freezing point. But osmotic pressure is a colligative property which we have studied. So the correct answer will be option 1, osmotic pressure. Moving on to the next question. The question says, the bond dissociation enthalpies of hydrogen and nitrogen are 436 kilojoule per mole and 941.8 kilojoule per mole respectively, and enthalpy of formation of ammonia is -46 kilojoule per mole, right? And we have to find out what is the enthalpy of atomization. So the enthalpy of atomization is same as the bond energy. Okay, so we need to understand that the formula for enthalpy of formation is, how do we calculate the enthalpy of formation? It is given as the sum of the bond energies of the reactants minus the sum of the bond energy of the products, right? So we have to find out this, the bond energy of the products, which is same as the enthalpy of atomization. So we have the enthalpy of formation given to us as -45 kilojoule per mole. And if we when we write the equation for the enthalpy of formation, we have to make sure that only 1 mole of product is being formed. Okay, so we'll have half mole of nitrogen and 3/2 moles of hydrogen. So for half moles of nitrogen, the bond dissociation enthalpy will be half of what is given, right? So it will be 470.9. And for 3/2 moles of hydrogen, we'll have to divide the bond dissociation enthalpy by 3/2. We'll have to multiply it by 3/2, so we'll get 654. And here we have to find out this term, right? So to find out this term, which is the enthalpy of atomization, we'll bring the enthalpy of formation towards the right hand side. So we'll get the sum of the enthalpies of the sum of the bond energies of the reactants, which is 470.9 plus 654 for hydrogen and it will be minus of minus 46. This is the enthalpy of formation. So we get the total enthalpy of atomization for ammonia as 1170.9 kilojoule per mole, which we can see is in option 2. So option 2 will be our correct answer. Moving on to the next question. The question says, what is the ratio of the radius of the fourth orbit of helium plus ion to the radius of the second orbit of the beryllium 3 plus ion? Okay, so we need to know that the radius is directly proportional to n square by z, right? So radius is directly proportional to n square by z. So if we write the ratio of the uh, radiuses of helium and beryllium, so we can write it as n of helium divided by z of helium, right? And this will be n square, sorry, right? And if we divide it by the radius of beryllium, so we'll have to divide by the n of beryllium and multiply by the, oh sorry, n square here, and multiply by the atomic number of beryllium, right? So if we substitute the value, we have the fourth orbit of He plus, so n will be 4 for helium and z will be 2 for helium because the atomic number of helium is 2, whereas the atomic number of beryllium is 4 and the orbit number is 2. So in total we get the radius of helium plus, and the ratio between these two will be equal to 8 divided by 1. So the ratio is 8 is to 1, which is in option 4. So the correct answer is option 4. Moving on to the next question. The question says the number of lone pairs present in the BRF3 molecule are. Okay. So in the BRF3 molecule, we know that bromine and fluorine both have 7 valence electrons. So bromine is the central atom, it is forming 3 bonds. So when it is forming 3 bonds, so after 3 bonds are used up, it will still have 4 valence electrons left. So from 4 valence electrons, we get 2 lone pairs. So bromine is carrying 2 lone pairs. Similarly, in fluorine, each fluorine is forming 1 bond with the bromine atom. So each fluorine, one electron is being used for bond formation. So it will have 6 electrons, as 6 electrons will be non-bonded, right? And they will be in the form of 3 lone pairs. So each fluorine will be carrying 3 lone pairs. So 3 for this, 3 for this, 3 for this. So in total, if we find out the total sum of the lone pairs on the entire molecule, it will be equal to 11. So the correct answer of this question will be option 4, which is 11. Moving on to the next question. The question says, an aqueous solution contains an unknown concentration of barium ions when 50 ml of a 1 molar solution of Na2SO4 is added. Barium sulfate just begins to precipitate. The final volume is 500 ml. The Ksp of BaSO4 is given to us as 10 raised to the power minus 10. So we have to find out what is the original concentration of barium 2 plus. So there is a lot of dilution occurring in this solution, in this question. So for dilution, what we do is that we have to keep in mind that M1V1 is equal to M2V2. Okay, when dilution occurs, so this formula comes in handy. So let us see. So 50 ml of solution of sodium sulfate, right? It's added and the final volume is made to be 500 ml, which means that the barium sulfate solution is 450 ml, and we are adding 50 ml of solution into this. Okay, so the concentration of sulfate in the barium 2 plus solution will become M1 multiplied by V1, which is the initial molarity. So initial molarity was 1, right? And the volume of the solution was 50 ml, and the final molarity we have to find out, and the final volume of the solution is 500, right? Okay, so the final volume of the solution is 500, so that gives us the molarity of sulfate ion. The concentration of sulfate ion will be finally equal to 1 by 10, right? So this is the final concentration of sulfate ion in the solution. So for precipitation to occur, the ionic product should be equal to the Ksp. So ionic product is the product of the concentrations of the ions. So for barium sulfate, the ions are barium 2 plus and sulfate 2 plus, and that should be equal to the Ksp of barium sulfate, which is given to us as 10 raised to the power minus 10. So from here, if we calculate the concentration of barium 2 plus, it will be 10 raised to the power minus 9 molar, but that is in the solution which is finally obtained, the 500 ml solution. But the question asks that what is the original concentration. So original concentration was the one which was in the 450 ml solution. So for that, once again, we'll use the formula M1V1 is equal to M2V2, right? And for the initial concentration, let the initial concentration be M. So the volume will be 450. The final concentration of barium is 10 raised to the power minus 9 and the final volume is 500. So when we calculate, we get the initial concentration of barium as 1.11 multiplied by 10 raised to the power minus 9 molar, which is in option 3. So option 3 is the correct answer for this question. Moving on to the next question. The question says, which of the following halides is isobutyl bromide? Okay, so we are given 4 different compounds and we have to find out which of the following is isobutyl bromide. So if we draw the structure of isobutyl bromide, what we understand from isobutyl is that it is iso means similar, right? So from butyl we understand that we have 4 carbon atoms, and from iso we understand that it is a symmetrical kind of molecule. So if we take a look at this compound, right? So this molecule is isobutane. Okay, so if I just remove one hydrogen from here and replace it with bromine atom, so I'll get isobutyl bromide. Okay. So this will be our isobutyl bromide, and that we can see is in option 4. Moving on to the next question. The question says, it's an assertion reasoning type question. So the assertion says that alkanes can exhibit an infinite number of conformations due to unrestricted rotation around the CC single bond. So this is a correct statement because we know that when the CC single bond rotates, so there can be infinite number of conformations possible, right? Because the atoms can take many different positions. So assertion statement is absolutely correct. But if we take a look at the reasoning statement, so reason says rotation around the CC single bond is completely free. So the rotation around CC single bond is relatively free. If we compare with other bonds, it's relatively free, but we cannot say that it is completely free because some steric factors and some electronic factors come into play. So the rotation is not completely free, right? So the statement, the reasoning statement becomes wrong. So the correct answer will be option 3, which says that assertion is true and the reason is false. Moving on to the next question. The question says, which element does not form a stable monoxide? And we have the group 14 elements, the carbon group. So we have options as lead, silicon, carbon, and germanium. So we know that carbon forms a stable carbon monoxide, right? Lead forms lead monoxide, and germanium forms germanium monoxide. However, silicon does not form a stable monoxide, right? Silicon forms a dioxide, and the dioxide is also in a network form of structure, right? As we can see in this diagram. So silicon forms a network of a dioxide. It does not form a stable monoxide. So the correct answer to the question will be option 2, silicon. Moving on to the next question. The question says the correct order of metallic character among silicon, beryllium, magnesium, sodium, and phosphorus is, right? So we have to find out the correct order of metallic character. So if we take a look at the compounds, we have silicon. Silicon is a p block element. Beryllium, magnesium, and sodium are s block elements, and phosphorus is also a p block element. So first of all, metallic character will be highest in the s block elements, and among beryllium, magnesium, and sodium, sodium is in the group 1, right? So sodium will be the strongest metal here, right? Sodium will be the strongest metal, followed by magnesium, and then it will be followed by beryllium because beryllium lies in the second period, so it has a higher ionization energy and is thus a bit weaker metal as compared to sodium and magnesium. Next, we have to talk about silicon and phosphorus. So silicon is a metalloid, so it shows some properties of metals and some of non-metals. So it, and whereas phosphorus is a non-metal, so it will not show any metallic character. So silicon will be more metallic as compared to phosphorus. So this will be the correct order of metallic character in the decreasing order. So sodium will be the highest, followed by magnesium, then beryllium, silicon, phosphorus. So correct answer will be option 2. Moving on to the next question. The question says, what is the highest oxidation state that a group 14 element can obtain? Right. So once again, we have a group 14 related question. So group 14 is the carbon group, right? It is the carbon group. And if we remember the electronic configuration of carbon, so if we talk about the valence shell, we have 2s2, 2p2, right? And after the excitation of one electron to the p orbital, we can get a total of 4 unpaired electrons, right? So the group 14 elements have only 4 electrons in their valence shell. So that means that they can have a maximum oxidation state of +4 only, because they don't have more electrons in the valence shell, so they cannot exceed the oxidation state of +4. So for example, we have CCl4 as well, and we have carbon dioxide. In both, the carbon shows up oxidation state of +4, and as we go down, the tendency to show +4 oxidation state keeps on decreasing because of the inert pair effect. So the correct answer here will be option 1, which is 4. Moving on to the next question, the question says, determine the molarity of the solution if 50 ml of water is added in 100 ml of 1 molar NaCl solution. So if we see, we have a question of dilution. So we just talked a short while back that for dilution we use the formula M1V1 is equal to M2V2. So we use this formula because the concept is that when we dilute a solution, so the amount of the solute remains same. So when we see the formula for molarity, so molarity is number of moles divided by volume. So to find out the number of moles, we multiply molarity by volume. So we get the number of moles. So the number of moles of solute is remaining constant when we are diluting the solution. So that is what we are doing. We are equating N1 to N2. So that is why we get M1V1 is equal to M2V2. So the final volume of the solution will be 50 ml plus 100 ml, which is 150 ml. And we have to find out the final molarity of the solution. So we have to find out M2. The V2 is 150 ml, and M1 is given to us as 1 molar, and the volume initial is 100 ml. So from here, if we try to find out M2, so we'll get M2 as 10 divided by 15, which gives us 2 by 3, which is equal to 0.67 molar. So the correct answer will be option 3, 0.67 molar. Okay. Moving on to the next question. The question says 100 ml of 0.1 molar HCl is neutralized by 50 ml 0.2 molar NaOH solution at 25 degrees Celsius. So we have a neutralization reaction between HCl and NaOH. The temperature of the final solution is increased by. So we have to find out the change in the temperature when HCl and NaOH are reacting. So first of all, we have 100 ml of 0.1 molar HCl. So if we find out the millimoles of H plus ions, so it will be 10. And if we find out the millimoles of NaOH, we multiply the volume by the molarity. So we also get 10. So the total number of H plus and OH minus ions reacting is 10. So the energy which is released when 1 mole of H plus and 1 mole of OH minus react is 57.1 kilojoule. So for 10 millimoles, what will happen is that for 10 millimoles, we'll multiply 57.1 multiplied by 10 to the power 3 joules, and we'll multiply it by the number of moles that we have, which is 10 millimoles. So 10 multiplied by 10 to the power minus 3. So from here we get the total amount of heat released on neutralization is 571 joules. So now we also know we need to find the change in the temperature, right? So we know the heat is given as Q is equal to ms delta T, where S is the specific heat of the solution. Also, we have to know the mass of the solution. So if we take a look, we have mixed 100 ml and 50 ml. So it gives us the total volume of solution as 150 ml, right? And for water, we can assume that density is 1. So 150 ml can be written as 150 grams. So the mass will be 150 multiplied by the specific heat, which is 4.2 joule per Kelvin per gram, and multiplied by the delta T. So delta T, when we calculate, it comes out to be 0.9 Kelvin, which is in option 3. So option 3 is the correct answer for this question. Moving on to the next question, the question says an atom has a mass of 0.02 kg and uncertainty in its velocity is 9.218 multiplied by 10 to the power 6 minus 6 meter per second. So the uncertainty in position will be. So we know from the Heisenberg uncertainty principle that del x multiplied by del p, which is the uncertainty in position multiplied by uncertainty in the momentum, is greater than or equal to h divided by 4 pi, right? So we have to find out the uncertainty in position. So we take the momentum to the right hand side, so we get the uncertainty in position as greater than equal to h divided by 4 pi m multiplied by the uncertainty in velocity, right? the uncertainty in momentum can be written as m multiplied by delta v. So we have all the values that we need. H is the Planck's constant, which is 6.6 multiplied by 10 raised to the power minus 34, and 4 we know pi is 3.14. Mass is given to us as 0.02, and the uncertainty in velocity is known as 9.218 multiplied by 10 raised to the power minus 6. So the final answer of this solution comes out to be, of this question comes out to be 2.8 multiplied by 10 raised to the power minus 28 meters. So that will be the uncertainty in position. Moving on to the next question. The question says, which is correct for dipole moment of NH3 and NF3? Okay. So we have the structures of NH3 and NF3. So we have to find out the net dipole moments of NH3 and NF3. So the relation between them. So if we take a look at ammonia, so one thing that we need to understand is when we talk about dipole moment, so dipole moment is towards the more electronegative atom, because the electronegative atom pulls the electron density towards itself. So the electron density shifts from the less electronegative atom towards the more electronegative atom, and that creates a dipole moment. And when we have a lone pair, so the dipole moment is always towards the lone pair. So in NH3 we have a lone pair here, right? So the dipole moment will be towards the lone pair, for the lone pair, and for each NH bond the dipole moment will be towards nitrogen. So the net dipole moment will be, all will be in the same direction, towards in the upward direction. So all will add up and the value of dipole moment will increase. However, in case of NF3, fluorine is more electronegative than nitrogen. So while the dipole moment of the lone pair is towards the upward direction, that for all the NF3 bonds is in the downward direction. So these dipole moments are in the opposite direction, which decreases the overall dipole moment. So the dipole moment for ammonia will be greater than that of NF3. So the correct answer will be option 2. Okay. Moving on to the next question. The question says, consider the following equilibrium. We have the equilibrium as N2O4 gas, and it is in equilibrium with 2 moles of NO2 gas. Then select the graph which shows the correct variation in concentrations of NO2 against the concentrations of N2O4. For this equilibrium, if we write the equilibrium constant, it will look like this: Kc, which is equal to concentration of NO2 raised to the power 2 divided by the concentration of N2O4. And if we see in the graphs, we have NO2 at the y-axis and N2O4 at the x-axis. So if we arrange like that, so we get uh, we get concentration of N2O4 is equal to uh, NO2 concentration whole square divided by Kc, right? And that is a y is equal to Kc x square type of equation. So that gives us the correct answer as option 3. Okay. Moving on to the next question. The question says, among the following, the compound with the maximum enol content is. So we have been given 3 different compounds, and we have to find out which will have the maximum enol content. So maximum enol content will be in that case when we have the most stable enol form, right? So if I draw the enol form for the first one, so what happens in keto-enol tautomerization is that the double bond is in conjugation with this alpha hydrogen. So the electron density shifts here while the hydrogen atom forms the bond with this oxygen. So it creates an enol. So for compound 1, the enol form will look like this, right? If we see for compound 2, so for compound 2, the enol form will look like this. And for compound 3, the enol form will look something like this. So if we see that in compound 3, we had 2 double bonds in the ring, and in the enol form 3 double bonds have been made, and the ring has become aromatic in nature, right? Phenol is formed and it is aromatic in nature. So aromaticity stabilizes the compound by a lot. So the enol form is highly stable, and that is why the enol content is maximum in compound 2. So the correct answer will be option 2. Moving on to the next question. The question says the product for the following reactions are. So we have 2-bromobutane in the first reaction, and it is being reacted with alcoholic KOH. So what happens when we react haloalkane with the alcoholic KOH? The alcoholic KOH carries out the E2 elimination reaction. So what happens is dehydrohalogenation takes place. So the bromine atom will be lost, right? And along with it a hydrogen atom will also be lost. So either this hydrogen atom can be lost or this hydrogen atom can be lost. But we know according to the Setzeff rule that a more substituted alkene is always formed. So instead of one butene, two butene will be formed, and we'll get the structure something like this for the compound as CH3 CH CH CH3. So this will be our compound X. Okay. If we take a look at the second reaction, in the second reaction we have we have an alkene and its ozonolysis is being done. So what happens in ozonolysis? Uh, let us see by a short trick what we should do from exam point of view for ozonolysis. The double bond breaks, right? So the double bond is cleaved and each carbon atom forms a double bond with an oxygen atom. So this is what happens in ozonolysis finally. So an aldehyde is formed here and a formaldehyde is formed. So if we take a look at our options, so option 3 will be the correct answer, right? X is 2-butene, and then we have two aldehydes formed in the second reaction as Y and Z. Moving on to the next question, the question says aqueous solution of orthoboric acid behaves as a weak monobasic acid giving H3O plus and so when orthoboric acid is mixed in an aqueous solution, what happens is that the orthoboric acid, which is H3BO3, right? It takes up hydroxyl ion from the water molecule, right? And it forms a BOH4 minus group, whereas it releases a proton or the H3O plus group. So H3O plus and along with it we form a BOH4 minus compound, right? So BOH4 minus entity is formed. So correct answer will be option 3. Moving on to the next question, the question says, what will be the correct order of increasing ionic radii for the given isoelectronic species? So we have been given isoelectronic species, it is S2 minus ion, Cl minus, P3 minus and K plus. So we know that for isoelectronic species, the ionic size is directly proportional to the negative charge. So more the negative charge, more will be the radius. Because what happens is that as the negative sign is increasing, it means that the number of electrons is increasing as compared to the number of protons. So the effective nuclear charge per electron decreases. So when the nuclear pull will decrease, so the electrons will be able to move farther away from the nucleus, uh, increasing the radius of the ion. Similarly, for a positive charge, more is the positive charge, lesser will be the ionic radius. So when we have a positive charge, so the ionic radius will decrease, whereas as the negative charge keeps on increasing, the ionic radius will keep on increasing. So the correct order will be like this: K plus will have the lowest ionic radius, followed by Cl minus, then S2 minus, and then P3 minus will have the highest ionic radii. So the correct answer will be option 3 here. Moving on to the next question, the question says, in MgF2, what is the oxidation state of fluorine? So fluorine is a highly electronegative atom, and when it is present as F2, at that moment fluorine is present as in zero oxidation state. Other than that, in all compounds, fluorine is always present in the -1 oxidation state, because fluorine is the most electronegative atom of all. So it is always in the -1 electron in the -1 oxidation state. Also we can see that magnesium is a second group element, right? It's a second group metal, so it preferably stays in the electronic configuration of Mg2 plus. So the oxidation state is +2, and if in MgF2, right, for MgF2 the two fluorine atoms will have to balance out the charge on the magnesium atom, so we'll have 2 multiplied by -1 for each fluorine atom. So fluorine's oxidation state will be -1. Moving on to the next question. The question says the molar elevation constant of water is 0.52 degrees Celsius kg per mole. The boiling point of 1 molar aqueous KCl solution is, assuming the complete dissolution of KCl, right? So to find out the elevation in boiling point, what we have to do is the formula for elevation in boiling point is given as delta T is equal to I, which is the Van 't Hoff factor, multiplied by Kb multiplied by the molality of the solution. So this Van 't Hoff factor, it takes into consideration the dissociation and association of the ions. So when dissociation is occurring, what will happen is the final number of molecules, right? The final number of ions or final number of particles will be double than the initial number of particles. So 1 KCl molecule gives us 2 ions, which is K plus and Cl minus. So the final number of molecules is 2 divided by the initial number of molecules, which is 1. So the value of I will be 2, and then we substitute the values of Kb, which is given to us as 0.52, and the molality is given to us as 1. So when we substitute the values, we get the delta Tb as 1.04. So now we have to find out the boiling point of the solution, the final boiling point. So that will be 100, which is the initial boiling point of water, right? 100 degrees Celsius plus the change which is occurring. So the final temperature becomes 101.04 degrees Celsius, which is in option 3. Moving on to the next question. The question says, which of the following lines correctly shows the temperature dependence of the equilibrium constant K for an exothermic reaction? Okay. So we need to find out the relation between the temperature, and we need to relate it to the temperature with for an exothermic reaction. So we need to include the enthalpy part as well. So we know that enthalpy is we know that free energy is given as delta H minus T delta S. And we also know that free energy can be related to the equilibrium constant as well. So that relation is delta G is equal to minus RT ln K, where K is the equilibrium constant. So we can equate both these equations and we'll get delta H minus T delta S is equal to minus RT ln K. So as we can see, the graph is between ln K and 1 by T. So if we write it in that form, we rearrange, we get ln K is equal to minus delta H divided by RT plus delta S divided by R. So this is a Y is equal to mx plus c kind of equation, right? Where the slope is given by minus delta H naught by R. And we have been given an exothermic reaction. So for an exothermic reaction, the value of delta H is negative. So when delta H is negative, so the slope will become positive. So for an exothermic reaction, the temperature dependence of equilibrium constant will always have a, it will be a straight line, and it will always have a positive slope. So for the graph, we can see the positive slope is in two lines, which is A and B. So the correct answer will be option 1. Moving on to the next question, the question says, which of the following combinations of quantum numbers could be valid? Okay, so we have been given 4 different sets of quantum numbers, and we have to tell which of the following are possible or which are valid, right? So for example, so when we start, when we have a certain value of n, so for a certain value of n, the values of L range from 0 to n minus 1. So if the value of n is 4, so L has to be less than or equal to 4. Okay, oh, sorry, it cannot be equal to 4. Sorry, L always has to be less than 4. So the value of L can be 0, 1, 2, and 3. Okay, so if we take a look at our options, so we can eliminate option 1 because here L is also 4 and N is also 4. Option 2 we can consider. In option 3 also we can eliminate because L is greater than N. And in option 4 again we have L is equal to N, which is not possible. So the only correct option remains as option 2. So in option 2, let's go through option 2. We have n is equal to 4 and the value of L which are permitted are 0, 1, 2, 3. So L is equal to 3 is given, so which is also allowed. M is equal to minus 2 and S is equal to minus half. So these all values are possible. So the correct answer will be for question number 81 is option 2. Moving on to the next question. The question says, on the basis of bond length, how many different types of bonds are present in the dichromate ions? So here we can see the structure of dichromate ions, which is given. The terminal, so if we take a look at this, we have two chromium atoms, right? The chromium atoms are joined together by a bridging oxygen, right? So we have two CRO bridging bonds and three terminal chromium oxygen bonds for each chromium atom. So what happens is these terminal bonds, these are double bonds, right? So the chromium forms a double bond with each terminal carbon, oh sorry, terminal oxygen. So here is a double bond, this is also double bond, and this is also double bond. So all these six CRO terminal bonds are of the similar type, and these bridging ligands, the bridging CRO bonds are of another type. So these are of the similar type 1 and these are of the similar type 2. So there are total two different types of bonds which is present in the dichromate ion. So the correct answer will be option 2. Moving on to the next question, the question says, What will be the pH of solution obtained by mixing 25 ml of 0.2 molar HCl with 25 molar of 0.2 molar barium hydroxide? Okay, so we have a base and an acid. So we have 25 multiplied 25 ml of 0.2 molar HCl. So if we find out the equivalents of HCl or the millimoles or the milliequivalents as we say, so the milliequivalents of HCl will be equal to it will be 25 multiplied by 0.2, which gives us 5 milliequivalents, right? We get 5 milliequivalents of H plus ion. Whereas if we calculate for OH minus, so for OH minus we have a 25 ml solution of 0.2 molarity. But if we take a look, we have barium hydroxide. So each molecule of barium hydroxide will release 2 OH minus ions. So that will give us 10 milliequivalents of OH minus. So as we can see that we have more equivalents of OH minus as compared to H plus. So when neutralization occurs, 5 milliequivalents of H plus will be consumed along with 5 milliequivalents of OH minus. So what will we be left with? We'll be left with 5 milliequivalents of OH minus, or we can also say that as 5 millimoles of OH minus. So if you find out the new molarity of OH minus, so the molarity can be written as 5 millimoles, which is 5 multiplied by 10 raised to the power minus 3, right? Divided by the volume of the solution. The volume of the solution will be 25 ml plus 25 ml, which is 50 ml. So 50, and to convert it into liters, you have to multiply it by 10 raised to the power minus 3. So this cancels out. We get the molarity of the solution as 0.1 molar. So this is the concentration of OH minus ions. So if we find out the POH will be 1, and that gives us the pH as 13. So the pH of the final solution will be 3, which is 13, which is option 3. Moving on to the next question. The question says, provide the correct descending order of nucleophilicity for the given nucleophiles, and we have been given 4 different nucleophiles. So what a nucleophile is? Nucleophile is a molecule which donates a pair of electrons. So it must either have a lone pair or it must have a negative charge. So when it has a negative charge, so the tendency of donation will be more. So we can straight up say, as we can see in 2, 3 and 4, we have a negative charge on the oxygen atom. So water will be the weakest nucleophile of all. So water will be the weakest nucleophile of all in these 4 given compounds. Okay, now if we take a look, at CH3O minus, right? So CH3O minus will be the strongest nucleophile because the negative charge is on the oxygen atom. There is no resonance of the negative charge, and also the methyl group. You see methyl group. So methyl group we know is an inductively donating group. So it applies a plus I effect, increasing the electron density on the oxygen. So that makes CH3O minus as the strongest nucleophile among the 4 compounds. So we can write 4 will have the highest nucleophilicity. Now, if we see next, we have OH minus. So on this also there is a negative charge on O directly. There is no stabilizing group on it. There is no resonance. So it will also have a strong nucleophilicity, but it will be less than CH3O minus because there is no inductively donating group on that. Next, we have CH3COO minus, right? So in this, the negative charge is also on oxygen, but it is less reactive. It is less nucleophilic because the negative sign is stabilized by resonance, right? In CH3COH, this is what the acetate ion looks like. So what happens is this negative sign is involved in resonance. So due to the resonance, it is stabilized, and thus it makes the compound less reactive. So 2 will be less nucleophilic, and we discussed that water will be the least nucleophilic because it is neutral and not negative. So the correct answer will be option 4 in this case. Moving on to the next and last question of section A. The question says, which of the following represents the correct order of acidic strength? So we have to talk about the correct order of acidic strength, and here we have hydrocarbons, right? And in hydrocarbons we have alkynes, alkenes, and alkanes. So in alkynes we have sp hybrid carbons, in alkenes we have sp2 hybrid carbons, and in alkanes we have sp3 hybrid carbons. So we know that for acidic character, right, there should be electron withdrawing effect, right? The electronegativity should be very high. So if we take a look, in sp we have a 50% s character. In sp2 we have how much s character? It is, sorry, In sp2 we have a 33% s character, and in sp3 we have a 25% s character. So the s character is decreasing, which means that the electronegativity will be decreasing. So the electronegativity will be highest for sp, and then sp2, then sp3, and similar will be the order for the acidic character. So if we talk about the acidic character, so the acidic character for the alkynes will be highest, then for alkenes, and then for alkanes. So the statement 1 is correct and statement 2 will be wrong. Now if we take a look at statement of for the options 3 and 4, we have alkynes in all of them, right? So we have to compare the acidic strength for the three different alkynes. So what is happening in this is we have three different alkynes. Let us draw them. We have CH3, C triple bond, CH. So this is the hydrogen that we'll be talking about, right? Here we have HC triple bond CH. This will be the hydrogen that we'll be talking about. And the another alkyne that we have is CH3 C triple bond C CH3. So here the hydrogen atom is bonded to a sp3 carbon atom, right? This is an sp3 carbon atom, so this compound will have the least acidic character of all, right? So it should be at the last. It is in the last for both the options. If we compare these two, so the acidic character will be more for this one. It will be more for ethyne as compared to propyne, because in propyne we have a extra methyl group. So the methyl group is donating electrons inductively, and when it donates electron, it destabilizes the carbon ion that will be forming. So the acidic character of ethyne will be maximum as compared to propyne. So the statement 4 will be correct, whereas statement 3 will be wrong. So the only correct statements are 1 and 4. These are the correct orders of the acidic character. So option 3 is correct. So that's it for section A. Now let's start with section B. Okay. So the question says the stability of +1 oxidation state among aluminium, gallium, indium, and thallium increases in the sequence. So we have to tell about the stability of the +1 oxidation state. So all of these four elements are present in the same group. Okay. So what happens as we go down the group, the stability of the +1 oxidation state will increase. This is because of the inert pair effect. So what is the inert pair effect? Inert pair effect is the reluctance of the elements of the p block elements generally, which we have in group 13, 14, 15, and 16. So they are reluctant to lose the electrons in their ns2 subshell, right? So they are reluctant to lose the electrons in the s subshell. And why does that happen is because as we keep going down the group, the size of the atom keeps on increasing, and the shielding by the inner electrons that are present in the d shell or in the f shell, it becomes more and more weak. So because the shielding is weak, so the s orbitals will be held tightly by the nucleus, and it will be more and more difficult to lose them. So what happens is that in aluminum group we have the final configuration is as ns2 and np1. This is the valence shell configuration. So they are reluctant to lose the ns2 electrons. So only the np1 electron will be lost, and +1 oxidation state will be more stable for the lower elements. So as we keep on moving down the group, the stability of +1 oxidation state will increase. So the correct answer will be option 2. Moving on to the next question, the question says, predict the position of an element which has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Okay, so we can see that the final electrons are being filled in 4s1 and 3d5. So since the fourth shell has been started to fill, that means the electron is in period 4. Okay, so the number of shells is same as the number of periods. So the electron will be, the element will be in the period 4. Now to find out the group of the element, we can just add the electrons in the s orbital plus those in the penultimate d orbital. So what do we get is that in the 4s1 we have 1 electron, while that in 3d5 we have 5 electrons. So if we add them, we'll have 6 electrons. So the group number will be 6, which is option 1. So the given element will be in period 4, group 6. Moving on to the next question, the question says, which of the following pairs will not produce any color in the flame when tested? And we have been given group 2 elements, which are calcium, strontium, magnesium, beryllium, right? So we have to tell which of the following will not produce a color in the flame, right? So what happens in the flame test is that the electron is excited by the flame, right? So the energy provided by the flame is enough to excite the electron to a higher energy state, and that shows a characteristic color. But what happens in the case of beryllium and magnesium? that beryllium and magnesium are very small in size. So because they are small in size, their valence electrons are tightly held. So when the electrons are tightly held, the energy in the flame is not enough to excite the electrons, right? So the electron will not be excited, and there will be no color in the flame for beryllium and magnesium. So the correct answer is option 3. Moving on to the next question. In the next question, we have a match the column type of question. So the question says, oh, sorry, we missed a question. So question number 89 says the minimum molar mass of a protein that contains 0.7% by mass of nitrogen will be, right? So if we talk about the percentage composition of nitrogen, so the percentage composition of nitrogen in the compound will be the mass of nitrogen, right, divided by the mass of the compound, right? The mass of protein we are talking about here, right? The molar mass of protein, and multiply that by 100. So the mass of nitrogen will be same as the atomic mass, right? Atomic mass multiply by its atomicity, right? The number of atoms which will be present in one molecule of the protein, right? Divided by the molar mass of protein multiplied by 100. Right, so that will give us the composition of the percentage composition of nitrogen. So the percentage composition of nitrogen is given to be as 0.7. We know the atomic mass of nitrogen to be 14, and it's the question asks the minimum molar mass. So for the minimum molar mass, we know that for minimum there should be as less amount of nitrogen as possible. So the least we can take is nitrogen atomicity to be 1, that one atom of nitrogen should be present in one molecule of the protein. So only one atomicity multiplied by 100 divided by the molar mass of the protein. So when we solve it, we'll get the molar mass of the protein as 2000 AMU. So the correct answer will be option 4. Moving on to the next question. The next question is a match the column type of question. So in the column 1, we have some expressions regarding the pressure, regarding the heat and everything. So using them, we have to find out the type of process which is occurring. So if we take a look at the first one, in A we have P external is 0. So P external is 0 means that there is no external pressure acting on the system. So when there is no external pressure, it means that the system is free to expand, right? There is nothing, no force being applied on the system, so the system can expand without any repulsive force. So that means for P external 0 is equal to 0, we'll have a free expansion of the ideal gas. So A will be matched to P. Next we have Q is equal to P external multiplied by Vf minus Vi. So we know that P external multiplied by Vf minus Vi is the formula for work done in an irreversible reaction, right? And since the work done is equal to the heat transfer, since the work done is equal to heat transfer, that means that we have the change in internal energy to be 0. And since the change in internal energy is 0, that means the change in temperature will be 0, and that means that we have an isothermal process. So B will be an isothermal irreversible process, so B will be matched to S. Okay, in C we have Q is equal to 2.303 nRT log Vf by Vi. So this is the formula for a reversible work done, right? And this also means that we have an isothermal process, so C will be matched to Q, which is isothermal reversible change. And in the last process we have delta U is equal to work done. So when delta U is equal to work done, that means the heat change is 0. So when Q is 0, we have a adiabatic system, so D will be matched to Q. If we see, we will have A matched to P, B matched to S, C matched to D, C matched to R, and D matched to Q. So the correct answer will be option 1. Moving on to the next question. The question says, what is the graphical representation of the energy of electrons as a function of the atomic number? So we have been given graphs between the energy and atomic number, the square of atomic number we have been given in the graphs. So the relationship between energy and atomic number is given like this. So energy is equal to minus 13.6 multiplied by z square divided by n square. So if we have to find the relation between the z square and energy, we can see that energy is directly proportional to the negative of z square. So if we draw a graph between energy and z square, we must have a graph with a negative slope because of this negative sign. So we must have a negative slope and the uh, E versus z square. So we must have a negative slope. There is no constant, so we have a y is equal to minus mx type of graph. So the graph will start from origin and it will have a negative slope and it will be a straight line. So it will go like this. So this we can find in option 4. So option 4 will be the correct answer to this question. Moving on to the next question. The question says back bonding is maximum in, and we have four options: BF3, BCl3, BBr3 and BI3. So we know that in BX3 type of compound, when boron forms a BX3 type of compound, it is an electron deficient compound. If we take a look at this, so boron has only 3 valence electrons, so it forms 3 bonds, but its 1p orbital remains empty. So what happens is the lone pair on the halogen atom will be back bonded to this empty p orbital of the boron atom. So what happens is that if we talk about fluorine, so fluorine has its electrons, its lone pair in 2p orbital. Chlorine has its lone pair in 3p orbital. Bromine has its lone pair in 4p, whereas iodine has its lone pair in 5p. So as we keep on moving down, so we see the number of shells increasing, and that will decrease the compatibility with the vacant 2p orbital of bromine. So the 2p orbital which is vacant will be most compatible with the 2p orbital of fluorine. That means that band bonding will be maximum in case of BF3, because both the electron receiving empty orbital as well as the lone pair both are present in the 2p orbital. Okay, so correct answer will be option 1. Moving on to the next question, it is an assertion reasoning type of question. So assertion says Kp can be less than, greater than or equal to Kc. So if we consider the relationship between Kp and Kc, so it is given as Kp is equal to Kc multiplied by RT raised to the power delta Ng. Okay. So delta Ng is, what is delta Ng? Delta Ng is the change in the number of moles of gaseous products, right? The number of moles of gaseous reactants and products that can keep on changing, right? We can either have it as negative or positive, or it can be zero. So depending on that, the value of Kp can be either less than or greater than or equal to Kc. So the assertion statement is absolutely correct. If we take a look at the reason statement, it says that the relationship between Kp and Kc depends on the change in the number of moles of gaseous reactants and products. So this is what we just talked about. So the reason statement is also correct, and it very well explains the assertion statement. So we'll go with option 1, which is assertion is correct, reason is correct, and the reason is a correct explanation for the assertion. Moving on to the next question. The question says, which of the following statements is incorrect? Okay, so we have been given 4 different statements, and we have to tell which of the following statement will be incorrect. Okay, so the statement 1 says free radical carbon ion and carbocation are reaction intermediates. So this is a correct statement, as we know that in reactions free radical carbon ion and carbocations are formed, but they do not stay as they are. So they react and they are only present as intermediates. Okay, so this statement is correct, so this cannot be our answer. If we take a look at statement 2, it says that reaction between methane and chlorine in the presence of sunlight is processed via free radical. So we know that when halogen reaction takes place in the presence of heat, so the heat homolytically cleaves the bond and forms a, a halogen radical. So this statement is also correct. So the statement 2 will not be our answer. If we take a look at statement 3, it says that the electronegative atom in carbon chain produces plus I effect. So this is a wrong statement, because we know that plus I effect is, it means that plus I effect means a electron donating inductive effect, right? So an electronegative atom, it tends to pull the electrons away from the carbon chain, right? So when a group is pulling electrons away, it is known as the minus I effect, right? So an electronegative atom applies a minus I effect, not a plus I effect. So statement 3 is incorrect, and this will be our answer. Okay, moving on to the next question. The question is, in the given reaction determine X and Y. So we have a ethyne, and it is first of all being reacted with NaNH2 and liquid ammonia. Then in the second step, it is being reacted to CH3CH2Br. That forms X, and when X is reacted with the same, we get Y. Okay, so we have to find out X and Y for the given reaction. So what happens is, when ethyne reacts with sodium amide in the presence of ammonia, the elimination of the hydrogen atom takes place. This hydrogen that is there, it takes place, as this hydrogen is acidic in nature, because it is attached to a sp carbon. So this will be acidic in nature. So we'll have the formation of this carbon ion, and it will be neutralized by the Na plus ion. Okay, so when this is reacted with ethyl bromide, right? So when this is reacted with ethyl bromide, what happens is a bond is formed here. So we get HC, triple bond C, and this C will form a bond with CH2, CH3. So this is our compound X. Okay, and when the same reaction is done, so this time this hydrogen will be lost and a CH2 CH3 group will be formed on the other side of the reaction. So X will be 1 butene and Z will be, and Y will be 3 hexyne. So the correct answer is option 1. Moving on to the next question, we again have a match the following type of question. In this we have the common names and the molecular formulae, and we have to find out which of the following match. So borax, as we know, borax is Na2B4O7, right? Sodium metaborate is NaBO2. ZSM5 is a zeolite, so C will be matched to 2. Whereas D is inorganic benzene, so inorganic benzene is B3N3H6, so D will be matched to option 1. So the correct answer is option 1, as A is matched to 3, B is matched to 4, C is matched to D, and D is matched to 1. Moving on to the next question. The question says, in the given reaction, X and Y are, right? In the reaction, we have Na2B4O7 dot 10H2, which is borax. It is being heated to give X plus sodium metaborate plus H2O. And then X is being reacted to chromium trioxide, and on heating, it is producing a green colored compound. So what we can see here is this is a borax bead test, right? So this reaction sequence is the borax bead test. So the borax bead test is done because it shows a characteristic color because of the metal ion here, right? So what happens in the borax bead test when we heat borax? So on heating, it forms sodium metaborate and boron oxide. It is a transparent bead. So X becomes B2O3, which is boron oxide, right? And when boron oxide is heated with the chromium trioxide, it forms a green colored complex, which is CrBO2 whole thrice. Okay, so this is green in color because of the chromium 3 plus present, right? So the correct answer will be option 3, because B2O3 is X and CrBO2 whole thrice is Y. Moving on to the next question, question number 98. It's an assertion reasoning type question. So the assertion says many elements commonly occur on the earth in the form of their oxides. This is a true statement because in many of the ores we see that the metals are present in the form of their oxides. And this happens because we know that oxygen is very reactive and oxygen is present in a good amount in the atmosphere. So when there is a lot of oxygen present in abundance, as well as oxygen is a reactive and electronegative gas, so it reacts with the metals, and most of the ores are present in the form of uh, the oxides. So assertion is the correct statement. In the reasoning statement, we have oxygen is present in the atmosphere in a good amount. So as we discussed, this is the correct statement, and it will also be the explanation to this. So we can say that option 1 will be correct, that both assertion and reason are true, and the reason is a correct explanation of the assertion. Moving on to the next question, again we have an assertion reasoning type question. So the assertion says, for isothermal reversible process, Q is equal to minus W, that is the work done by the system, equals the heat absorbed by the system. So this is a correct statement, as we know according to the first law of thermodynamics, we know that delta U is equal to Q plus W. So for an isothermal process, what happens is delta U becomes 0 because the change in temperature is 0. So when the delta U becomes 0, so we get Q plus W is equal to 0. So we get Q is equal to minus of the work done. So this statement is absolutely correct. The assertion is correct. Uh, if we talk about the reasoning statement, the reason says enthalpy change delta H is 0 for isothermal process. So for an isothermal process, the change in enthalpy is 0. That is absolutely correct because enthalpy depends on the change in temperature as well. But in an isothermal process, the delta T is 0. So the delta H will also be 0. So this statement is correct. But is this statement an explanation of the assertion? No, because the enthalpy change has nothing to do with the uh, relationship between heat and work done, that is determined by the first law of thermodynamics and the value of delta U. So we can say the statement 2 will be correct. Assertion is correct, reason is correct, but the reason is not a correct explanation for the assertion. Moving on to the last question of chemistry, we have an assertion reasoning type question. The question says, we have the assertion. The assertion says when a covalent bond is formed between atoms of different electronegativity, the electron density is more towards the more electronegative atom of the bond, right? So this is the correct statement because we know that an electronegative atom, it will always try to pull the electrons towards it. So when we have a covalent bond, suppose in between two atoms A and B, so if B is more electronegative, so what happens is that it will pull the electron density towards it, right? It will try to pull the electron density away from A. So the electron density will shift like this towards B instead of equally spread out. The electron density will be more towards the more electronegative atom. So this creates a dipolar, this creates a dipole and the bond becomes polar, right? So assertion is the correct statement. If we talk about reason, so the reason says that the shift of electron density results in a polar covalent bond. So this statement is also correct, but the reason statement does not explain in the assertion step. So that is why we can say that both assertion and reason are correct, but the reason is not the correct explanation of assertion. So option 2 will be correct. So that is all for the part test 2 chemistry portion. Hope you all understood it well. Keep studying. We'll meet soon. Thank you.